Hello guys, welcome back to Zeph Academy. Today I am going to discuss with you about the ratio of some specific angles in trigonometry. So till now we had not defined the value of the angle. It was defined as either angle C or angle B or in some case angle A or in some cases angle theta. That means the angle was not having any value. So now what if we will be assigning certain values to the angles, and if we do that, what change or what values it will be giving us to our trigonometric identities, that is sine, cosine, tangent, and the reciprocals of them, cosec, sec, and cotangent. So let us begin with considering the case when the angle taken into consideration is 45 degree. So let us frame one triangle. Let us name it as ABC, and B will be at the right angle, and we will be assuming that our angle C is equal to 45 in this case. And of course, if C is 45, A will also be equal to 45 because of this fact that the sum of all the angles of a triangle is equal to 180. If you calculate, you will get the value of A is equal to 45 degree. Okay, now I am proceeding ahead by assuming one side of a triangle, that is AB, is equal to x. And of course, if AB will be x, BC will also be equal to x. I hope you remember this theorem that the sides opposite to the equal angles of a triangle are equal. In this case, A and C are the angles with the same value. That means the sides opposite to them, which in this case is BC, that is opposite to A, and AB, that is opposite to C, will be equal. That's why I wrote here that BC will also be equal to x. And of course, we will be able to find out the value of AC by applying the Pythagoras theorem. And that's how we get the value of AC. Once we get this value, just put it here on the triangle, which will ease out the process of finding the values of the trigonometric identities. So let's begin with the first identity, that is sine 45, which will be equal to 1 by root 2. Of course, now you are well aware with the formula that sine is opposite divided by hypotenuse. So it will give you this value. For cos, it is adjacent side of angle divided by hypotenuse will give you the value which is 1 by root 2 again, and tan 45 will be equal to 1. So these are the values you are getting for the angle taken into consideration 45 degree. Let's proceed ahead and let's consider the case when the angles are either 30 degree or 60 degree. So once again, I will be assuming this time that my triangle is equilateral triangle. It means that all of my angles will be equal to 60 degree. Because of the same fact, summation of all the angles is equal to 180. The triangle is equilateral. That means all the angles are equal and all the sides are also equal. I will be drawing one perpendicular line from angle A, which will reach to the side BC and meet at point D. Okay. Now this will basically divide my triangles into two parts. One part will be ABD, means one triangle ABD, and one triangle ACD. And both of these triangles are identified to be congruent to each other by AAS theorem. Now how this AAS theorem is taken into consideration is because of the fact that angle B will be equal to angle C of this triangle. Angle D will be once again the same, and they are sharing the same common side, that is AD. Also, I think so the AB side, AC sides are equal, so by AAS theorem, that is what? The two angles and the non-included side, which can be either AD, which can be either AB in both the cases. Okay, so because of this AAS theorem, these two triangles are congruent, which means that angle BAD is equal to angle CAD, these angles. Okay, of course, by CPCT, corresponding parts of the congruent triangle. Let's proceed ahead and let's try to figure out the angle values, which will be equal to 30 degree. Okay, of course, because the AD will be acting as a bisector as well of the entire angle A. That means that BAD will be 30, CAD will be 30. Okay. So now once you get the value of angle A, in the case of triangle ABD, B will be easy to find out, and of course we know B already. From the very beginning I mentioned here that my triangle is equilateral, that means B will be equal to 60 degree anyways. Okay, and also you have to note that BD will be equal to CD, because once these two triangles are congruent, then we can say that BD and CD will be the corresponding parts of the congruent triangles, and therefore they are equal to each other. Okay, now I am proceeding ahead by assuming the measurement of one of my side, that is AB, will be equal to 2x. That means AC will also be equal to 2x and BD will be equal to x. Now why that you know very well, because if AB is equal to 2x, that means that all the sides of the bigger triangle ABC will be equal to 2x, and BD is equal to half of BC, because this is the bisector as well, and because of the fact that BD is equal to CD, that means what? This point D is basically the midpoint of the side BC. Therefore, we can say that BD will be equal to half of BC, and therefore it is equal to x. Okay, and the side AD will be able to calculate it by using Pythagoras theorem, by focusing on the triangle A, B and D. Okay, so once you get the value of AD, I think so, now we should be focusing on the triangle. Okay, so now I'm focusing only on triangle ABD. Now we have the angle value as well, the sides value as well. How we got these values, you know very well. So let's begin by the case of considering angle 60 first. So sine 60 will be equal to the opposite side divided by hypotenuse again. In this case, if 60 is taken into consideration, opposite side will be AD and hypotenuse will be AB. That means it is root 3 by 2. For cos 60, the adjacent side will be BD, because BD is adjacent to this angle. Therefore, the value will be equal to half, and tan 60 will be equal to root 3. Okay, once this is done, now we shall be focusing on the angle A, which is having the value of 30 degree. So let's focus on that, and now we shall be writing down the formula with respect to angle A, that is with respect to angle 30. And when we take this angle into consideration, the opposite side to this angle becomes BD, right? And the adjacent side becomes AD. Please do not make a mistake and do not write down AB as the adjacent side, because AB is the hypotenuse. So AD will not be taken as the adjacent side. In fact, it is not the side, it is hypotenuse. So AD will be the adjacent side and BD will be the opposite side now for angle 30. So that's how you will get the value for sine 30, cos 30 and tan 30. These are the values. Okay, the important part for you to understand here is that how we are deriving or how we are calculating the values of the angles by taking the specific angles into consideration. We did for 45 degree and now we are done for 30 and 60 degree. Okay, now we shall be discussing about the case that if your angle is equal to 0, what will happen? So let's see that fact, that if your angle that was initially 60 degree, and if we try to minimize it up to the extent that it reaches basically 0 degree, that means what? This hypotenuse, which was AB earlier, it somewhat superimposes or aligns itself in this line BD, such that BD will be equal to AB now, and the height of AD becomes equal to 0. So what will happen and what values you will be getting for the trigonometric identities? Let us see. That sine 0 will be equal to 0, because now AD is equal to 0. That means what? Your sine of 0 degree will be 0. For cos 0, the value will be equal to 1. Why? Because of the same fact that adjacent side divided by hypotenuse, and in this case now your adjacent side, that was BD, is equal to AB, that is hypotenuse. That means your cos of 0 degree will be equal to 1 now. And similarly, the tan 0 will be equal to opposite divided by adjacent, but opposite is 0 because AD is now gone. That means your tan 0 will be equal to 0. I'm once again putting this page here for you to understand the triangles, at how the angle is decreasing up to 0 degree, and once it reaches there, how the value of AD becomes equal to 0. As you can see that AD is gradually decreasing in size, and it reaches the point where AD is approximately equal to 0. That means what? AB will be aligning itself into BD. I hope that is clear with you. Similarly, we shall be taking the point into consideration about the case where the trigonometric ratio is equal to, where the angle is taken equal to 90 degree. So what will happen? So likewise, we decrease this angle in the previous case to make it 0. Now we shall be increasing it such that it will be becoming equal to 90 degree. Can you see the changes happening here? That 60 it was, then it increase in size gradually, and it reaches this part where it almost aligns itself with the side AD, and it actually results in decreasing of the side BD such that it is almost equal to 0, just like this. And in this case, now the AB will be equal to AD, means the hypotenuse will be equal to now the side measurement AD. So let's see what happens when 90 degree is taken into consideration. At that moment of time, you will be getting the sine of angle 90 equal to 1, because the opposite side divided by hypotenuse, and now opposite side and hypotenuse are one and the same. AB is equivalent to AD, and that means it is equal to 1. Cos 90 will be in this case 0. Why? Because your adjacent side has been almost 0, that is BD, and tan 90 will be not defined here. I have written that thing specifically. Why? Because we are getting a denominator 0, so we cannot define that value. So tan 90 will be written as undefined or not defined value, which means we will be able to represent all these angles 0, 30 degree, 45 degree, 60 degree and 90 degree for all the trigonometric identities into this table in this manner. See, whatever value we calculated for 0, 30, 45, 60, 90 of sine, cos and tan, we have just write it down here. So this table you must be also having in your reference books which you are referring, but how these angles are calculated, that we just discussed. And obviously from these three identities, it is very much easy for you to get the values for the remaining three, that is cosec, sec and cot. Obviously, because of the fact that cosec will be the reciprocal of sine, and reciprocal of sine 0 is not defined, because in this case 0 will be once again in the denominator. So cosec 0 will be not defined. Then cosec 30 will be 2, which is the reciprocal of half, that is of sine A, sine 30. Similarly, the cosec of 45 will be root 2, once again the reciprocal of sine 45, and cosec 60 will be 2 divided by root 3, the reciprocal of sine 60 degree, and cosec 90 will be equal to 1, the reciprocal of sine 90. Similarly, as you can see here, sec will be the reciprocal of cos, and cot will be the reciprocal of tan. So these are the values which we just calculated by considering the certain specific angles 0, 30, 45, 60 and 90. So I hope you understand that how we derived all these angles and how we calculated the values of the trigonometric identities. Okay, so that was it for today, guys. We shall be meeting again, and now we shall be discussing about the numericals by considering these specific angles. Till then, take care of yourself. Wish you all the best of the learning, and please do not forget to subscribe to our channel. Thank you very much.